The JVM doesn't run your Java code directly. It runs bytecode, the portable instruction set produced by JVAC, and it has to decide how to turn that bytecode into real machine code for your CPU. Think of the JVM as a cartoon robot standing at a conveyor belt, staring at a switchboard with 3 levers and asking, "How should I run this?" Flip the Xint lever, and the robot puts on its reading glasses. Now every single bytecode instruction is decoded and executed one at a time forever. Startup is instant because there's nothing to compile, but steady-state performance suffers because every line gets retranslated on every pass through the loop. This is the patient librarian of execution modes. Flip the Xcomp lever and the opposite happens. Before any method runs, the JIT compiler grinds through the entire program and translates every method into native machine code up front. Startup crawls because that massive compilation pass happens first, but once it finishes, execution can be blisteringly fast with no warm-up phase at all. This is why tiered compilation, the default mode triggered by Xmixed, is the real genius. Every method starts its life in the cheap interpreter, so you get instant startup. Once a method gets hot, meaning it's been called enough times or sits inside a hot loop, the C1 compiler steps in to compile it to optimize native code. Later, if it stays hot, C2 takes over with even deeper optimizations. Best of both worlds. So when does code count as hot? By default, the JVM uses 2 thresholds. Roughly 10,000 invocations or loop iterations trips the C1 compiler, and roughly 100,000 escalates that method to C2. Until either threshold is crossed, the interpreter is doing all the work. Watch the thermometer. Blue is cold, red is hot, and steady-state performance only kicks in once the needle climbs. And here's the punchline. Compare them on a single chart. Xint starts instantly but stays slow forever. Xcomp starts agonizingly slow and stays fast, and Xmixed starts fast, takes a brief warm-up dip, then runs fastest of all. So if you're running a short script, Xint might actually win. But for any long-running JVM server, leave Xmixed on and let the JIT do what it does best. Welcome. We're about to see how the JVM's 3 execution modes change the speed of the exact same program. We'll write a small Java loop, run it 3 times with different flags, and compare the timings. The point is that what the JVM runs is identical, only how it executes changes. We start by clearing the screen and confirming the Java version. The output tells us we're on OpenJDK 17, and notice the phrase, mixed mode sharing. That's the JVM's default behavior, which is what we'll first benchmark and then override. Now we create a minimal Java file t.java using echo. It contains a single class whose main method sums the integers from 0 to 10 million and prints the total. A tight numeric loop designed to be hot enough for the JIT compiler to care about. We compile with JVAC, which turns t.java into t.class. There's no output on success, a silent green light that the bytecode is ready. From this point on, every test runs the exact same compiled class. Only the JVM flags change. First run. Xint forces pure interpretation, no JIT compilation at all. The loop executes strictly by reading bytecode, which is why we expect this to be the slowest of the 3. The result 4999995000000 confirms the math, and the real-time value gives us a baseline to beat. Second run. Xmixed is the default. The JVM interprets first and only JIT compiles the hot methods. Since our main loop runs millions of iterations, the JIT kicks in and we should see a dramatic drop in runtime. Watch how the real-time falls. Third run. Xcomp forces eager compilation of every method at startup, no interpretation. Startup is heavier, but peak execution is fully native. Compare this real-time to the previous 2. And notice that mixed mode was actually competitive because the loop is genuinely hot. The same loop, the same bytecode, the same correct answer, but 3.842 seconds interpreted, 0.412 seconds mixed, and 0.387 seconds fully compiled. Pure interpretation is roughly 10 times slower than the JIT, while mixed mode already gets you nearly all of the speed up because it only pays the JIT cost where it pays off.